Okay, in this first one is the balancing of reciprocating engine. So in this, just all of you observe that. So how to be balancing of the our reciprocating engine. So that is also very important. So if it is not properly to be balanced, then we should also face the some dynamic forces. Okay, problem with the dynamic forces and some vibrations. So how to be balanced? So this one. So just all of you observe that. So in this, they may said one thing, that is the resultant of all the forces acting on the body, on the engine due to the inertia forces, is known as the unbalanced force or shaking force. That means what are the forces are attaining, okay, due to the inertia forces. So that is known as the unbalanced force. That is calling as the unbalanced force or shaking force. So in this, uh, they may said, so that is the resultant of all the forces due to inertia effect is zero. Then there will be no unbalanced force. When the inertia effect is going to be zero, then there is no unbalanced force. So that will happen in our particular system. So now what are the forces are there? First, we will also know the those forces. So just all of you observe that. Let us take the reciprocating engine mechanism. So that is the our single slider crank chain. It is also similar. Just all of you observe single slider crank chain mechanism. In this, they are representing the some forces. Just all of you observe that. Those are the F suffix R. F suffix R. So F suffix R means force required to accelerate the reciprocating parts, where we are representing the FR value. So just all of you observe that FR is there. And next one is the some notations are there. Those are the F suffix I. So F suffix I means inertia force due to the reciprocating parts. And another one, F suffix N, that is the force on the sides of the cylinder. Force on the sides of the cylinder walls or normal force. It is also calling as normal force. And another one is the F suffix B. F suffix B. So F suffix B means force acting on the crankshaft bearings. Force acting on the crankshaft of the bearings. Just you will observe that. So those are the forces are involved in our reciprocating engine mechanism. So in this, when the crank is rotating with uniform velocity, uniform angular velocity omega, so then some forces are okay. Some forces are producing here. So those are the forces representing in this place. Okay. Now F suffix U is also there. F suffix U. This is known as the our unbalanced force. This is the our unbalanced force. So now we will okay, how to be balancing of the our okay, that mechanism. So that is also very important. So for getting this one, so let us go to the our next one. So primary and secondary unbalanced forces of the reciprocating masses. So here they may also representing two types of unbalanced forces. So those are the primary and secondary unbalanced forces. So in this, let us consider the reciprocating engine mechanism. In this, first you will observe the our symbol notations. So what are the symbols are there? Small m is the mass of the reciprocating parts, and L is the our length of the connecting rod. Small r is the radius of the crank, and theta is the angle of inclination, and omega is the angular speed of crank, and n is very important. Ratio of the length of the connecting rod to the crank radius. It is very important. N equals to L by R. N equals to L by R. So in this, so first they will write the our acceleration of the reciprocating parts. So they may also write the equation belongs to the our acceleration of the piston. Acceleration of the piston. So what is the value of acceleration of the piston? So this is already okay covered in our earlier in our earlier subject, that is the com. So in our com subject already have done this value. So that is the our a suffix r, okay, reciprocate acceleration of the piston. So that value is a suffix r representing with a suffix r equals to omega square r into cos theta plus cos 2 theta by n. Here the acceleration value is the omega square r cos theta plus cos 2 theta by n. So and once we remind the our velocity, already we have done velocity value is velocity of the piston is how much? So anyone could tell the velocity value? So that is the omega r sin theta plus sin 2 theta by 2n. Okay, so that is the our velocity of the piston. So this is the acceleration of the piston. So now here we will find out the our inertia force due to the reciprocating parts, or force required to accelerate the our reciprocating parts. That value is the inertia force equals to our force required to accelerating the reciprocating parts. Both are equal. Why? Because so when we start the engine, so that is what is the resultant force is the what is the resultant force is there, that force is overcome to the our inertia force. So that is definitely will happen. So how it is possible? So first let us find the our inertia force. Inertia force means, what is the inertia force? Inertia force equals to mass into acceleration. So that may also F equals to ma. So already known formula it is that. So similarly it is also equals to our force required to okay accelerate the reciprocating parts. That is also equal. So when we start the our engine, so that is also there. So when it is, so that value is how much? Yeah, a is already written in earlier. So and mass is the small m. So m omega square r cos theta plus cos 2 theta by n here. Cos theta by cos theta plus cos 2 theta by n here. So in this both are acting as the our, just you will observe that. So one is okay inertia and another one is the okay resultant or required force. So that is there. So both are equal, but the thing is those two are in opposite. Okay, equal and opposite to the okay the inertia force is opposite in direction. So that is the thing is there. So now so therefore here uh, unbalanced force, unbalanced force F suffix u is also equals to m omega square r cos theta plus cos 2 theta by n. Just you will observe that F suffix u equals to m omega square r cos theta plus cos 2 theta by n. So this equation is a splitting of the two terms. So that is the m omega square r cos theta plus m omega square r cos 2 theta by n. Cos 2 theta by n. When we are splitting of the two terms, so then those two are calling as first one is calling as the primary force and the second one is calling as the secondary force. So that is the primary force is okay representing with m omega square r cos theta, and secondary one is represented with m omega square r cos 2 theta by n. So just observe that. So when we write the our primary unbalanced force Fp equals to m omega square r cos theta, and secondary equals to secondary unbalanced force is the m omega square r cos 2 theta by n. In this, they may also given some cases. So those cases will represent where we get the our primary force is maximum. So that is the our, when we take the our theta value is 0 or 180 degrees, then the force value is going to be maximum. So then similarly to write the our secondary forces. So the secondary forces is also similarly to take the maximum values at the positions of theta equals to 0 and 90 and 180 and 360 degrees. Why? Because 2 theta is there. 2 theta is representing here. So where we get the our maximum secondary forces, those are representing here. And in this, the third one will representing here. So the secondary unbalanced force is 1 by n times the maximum primary unbalanced force. So they may also write the relation between the our secondary to the our primary of the our maximum forces. So that is also there. Fp maximum is m omega square r, and Fs maximum is m omega square r by m. So what is the difference is there between the primary force to secondary force? Please turn off your mic. Please turn off your mic. Roll number 323. The third condition, the third one will represents the difference between the our maximum secondary unbalanced force to the maximum primary unbalanced force. And fourth one, going to the fourth one. So in case of moderate speeds, the secondary unbalanced force is so small that it may be neglected compared to the primary unbalanced force. So in this, they may also said that moderate speeds, when we take the moderate speeds, secondary unbalanced force value is very less compared with the primary unbalanced force. Okay, so that's why they are neglecting. So that thing will happen in our case 4. And the fifth one represents the unbalanced force due to the reciprocating masses varies in magnitude but constant in direction, while due to the revolving masses. So they may also indicating here the unbalanced forces due to the reciprocating masses. Okay, magnitude is same, but the directions are different. So that may also already said in our earlier. Uh, so that is the our Fi equals to Fr is there. So that means inertia force is also equals to required force. So that is also there. Now, next topic, partial balancing of unbalanced primary force in reciprocating engine. Partial balancing of unbalanced primary force in reciprocating engine. So, how to be balancing of our primary force? Just let us take the only primary force point of view. So, how to be balancing of the our this one primary force? So in this, just observe that the primary unbalanced force already known. So that is the our m omega square r cos theta, already known that one. So in this, just you will observe the our uh, reciprocating engine mechanism. So that is the our what are the forces are there. Okay, so it seems it is okay, single slider crank chain mechanism. Just you will observe that. So the crank, what is the crank is there? The crank will carries the, for example, it will carries the some mass. The crank will carries the some mass. So then just you will observe that that mass value is m is there. So when it is rotating, while it is rotating mode, so then the centrifugal force will occur by the help of our mass. So that is the m omega square r is there, m omega square r. So that is the forces. So what are the forces are attaining? So that will representing here, that is the m omega square r at the crank pin. Okay, so that is there. And when we are taking to the this value, so then this horizontal component, why? Because it is also having some inclination. So that component is there, that component is the m omega square r cos theta. So m omega square r cos theta. Their horizontal component value is m omega square r cos theta. While while we are having the mass m is placed, okay, mass m is there. This is the assumption, okay, this is the observer assumption, okay, when the crank has to carrying the some mass, okay. So this is the assumption. Why? Because we may also have the some forces, we may get the some forces. So that forces okay, will not visible. So that's why we are also representing here is some mass is there. By the mass it may also have the some force, it may produces the some forces. So that force, okay, is there. So now for balancing of that mass, they may also arranging the balancing mass to the opposite side. They may also arranging the balancing mass to the opposite to the our crank side. So that is the just observe that. So what is the okay thing is there. So that balancing mass is representing with a small b. Balancing mass is representing with small b, and their radius value is the small b. Okay, this is the capital B representing with their mass capital B, and their radius of rotation is the our small b. So then if we write the our centrifugal force of the this balancing mass, so that is the b capital B omega square small b, capital B omega square small b. So that is the their force. So it is also followed the some inclination. So that's why this force is resolving the two components. Those are the b omega square b cos theta and b omega square b sin theta. So those are the forces are there. Okay, now have a okay one doubt here. So that is the when we are taking to be okay this one. So that is the our centrifugal force m omega square r. So it is only giving to be only horizontal component, not giving to be our vertical component, not giving to the vertical component. So that is there. So that is the small difference is there, okay, between the our mass to the our unbalanced mass to the our balanced mass. So that is there. When the system will happen, so this will produces the crank will produces only to the horizontal component. Okay, so that is just all of you remember and keep up in your mind. Okay, keep it in your mind. So now we are going to okay derivation part. So we know that centrifugal force due to the mass capital B, centrifugal force due to the mass, that value already written, that is the b omega square small b. Now the horizontal component of this force acting in opposite direction of the primary force. So that is also there. So that is the our horizontal component towards going to the right side, this one. Okay, so that is the opposite direction. So that value is how much horizontal component, capital B omega square b cos theta, capital B omega square b cos theta. Now the primary force is balanced. The primary force is going to be balanced if that thing is b omega square b cos theta is equals to m omega square r cos theta. B omega square b cos theta equals to m omega square r cos theta. Why? Because horizontal components, okay, they may also, one is going to be left side, okay, and another one is going to right side. So the right side thing is the okay, that value is the b omega square b cos theta, and left side is traveling with the our m omega square r cos theta. So while both are taking to be equal, okay, for when the balancing of the primary force. So then what are the similar components are there, those are cancellating here, that is the omega square and cos theta, and the remaining term is capital B small b equals to mr, capital B and small b equals to mr. So they may write here, but the thing is, definitely we may also have the some fraction. Okay, some fraction between the our capital bb to our mr, both are not equal, both are not equal, exactly not equal. So how to be differentiate, okay, to the our capital bb to the mr? So that is, they may also consider here, so, small c is there, that is the fraction of reciprocating masses, small c is there. So that's why they are arranging here, they are okay, uh, they are insert to that symbol, that is the capital bb, okay, bb equals to cmr. So that is represented with cmr, fraction of reciprocating masses is also multiplied with the our, okay, unbalanced mass to the our radius of rotation. Capital bb equals to cmr. So why? Because both are not exactly equal. So they may also representing with that small, okay, fraction value. So that fraction is there. Now cmr equals to bb. Okay, done. Now we are going to write the our forces. So that is the unbalanced forces. Unbalanced force along the line of the stroke. Unbalanced force along the line of the stroke. So I write the horizontal components along the line of the stroke, means horizontal components. What are the horizontal components are there? M omega square r cos theta minus b omega square b cos theta. Why? Because one is going to right side, and another one is the going to left side. So that's why this one will representing with the, okay, one is representing with negative symbol. So while we write the m omega square r cos theta minus, here bb is replacing with cmr. Okay, bb is replacing with cmr, c m omega square r cos theta. So now unbalanced force along the line of the stroke value is how much? 1 minus c into m omega square r cos theta. 1 minus c into m omega square r cos theta. So unbalanced force along the line of the stroke value is 1 minus c m omega square r plus theta. Now going to write the unbalanced force along perpendicular to the line of the stroke. Perpendicular to the line of the stroke. That value is the only one vertical component is there. That is the b omega square b sin theta. B omega square b sin theta. So it is also written as cm omega square r sin theta. Cm omega square r sin theta. Why? Because our unbalanced force. So that is the, what is the assumption is there? Observer assumption is there. So the total thing is this is the totally assumption of the observer. So in that thing, so our force, okay, unbalanced force, what is the unbalanced force is there? M omega square r is there. So that doesn't have the our vertical component. Okay, vertical component. So that's why only we are having the our perpendicular to the line of the stroke is cm omega square r sin theta. So now going to find the resultant. So this is the horizontal component is there and the vertical component is there. So now going to write the our resultant unbalanced force. So that equals to square root of horizontal square, okay, horizontal forces and vertical forces. Those are the 1 minus cm omega square r cos theta square plus cm omega square r sin theta whole square. So when we write that, m omega square r into, okay, common terms or similar terms are taken out from the square, and m omega square r into square root of 1 minus c square cos square theta plus c square sin square theta. So now they are also given here one thing. So that is the if balancing mass is required to balance the revolving masses as well as reciprocating masses. Here uh, reciprocating masses and revolving masses both are there. Just all of you observe that both masses, reciprocating masses and revolving masses. So that is balancing mass is okay required to balance these two components. Those are the capital BB equals to okay BB equals to M1R plus CMR. So this is very important, M1R plus CMR. So that means balancing mass is required to balancing the revolving masses plus as well as reciprocating masses. In this they are representing here. So M1 represents, small m1 represents magnitude of the revolving masses, and small m represents magnitude of reciprocating masses. Okay, so if you will find out the balancing mass, then simply to substitute this equation. So that is the small b capital BB equals to M1R plus CMR, M1R plus CMR. Okay, or it is also written as M1 plus CMR, M1 plus CMR. So that is there. So just all of you observe the problem regarding the earlier topic. Just you will see that a single cylinder reciprocating engine has speed 240 rpm and stroke 300 mm and mass of reciprocating parts 50 kg, mass of reciprocating parts 50 kg just, and mass of revolving parts at 150 mm radius 37 kg. If two-thirds of reciprocating parts and all the revolving parts are to be balanced, two-thirds of the reciprocating parts and all the revolving parts are to be balanced. So now find the balance mass required at the radius of 400 mm. Balance mass required at the radius of 400 mm. The second one, the residual unbalanced force when the crank has rotated 60 degrees from TDC, top dead center, 60 degrees. The angle will be given 60 degrees. So now from the problem description, all of you should write the our given values. What are the values are there? Just write it here. So that is the n equals to 240 rpm. So when we know the n value, then simply find the omega. So that is required for making the problem. So omega equals to 2 by n by 60. So the value is 25.14. Okay. And the stroke equals to 300 mm. This is also converted into the our meters, 0.3 meter. And m is the okay, small m is the our 50 kg, and revolving parts. Okay, so that is the m1 is the 37 kg, and small r equals to 150 mm. Small r equals to 150 mm. So that is also 0.15 meters. And c fraction is also given. So the fraction value is how much? So that is the two-third. Okay, two-third. That means already said in our statement. That is the if two-third of reciprocating parts and all revolving parts are to be balanced. So that is the fraction is also given, c equals to two-third. Okay. Now, first let us find the our balancing mass. So at the radius of 400 mm. Okay, that is there. Balancing mass required is the capital B is the balancing mass representing with capital B, and small b is the radius of rotation. Okay, that is there. Now let us take the only our equation, balancing mass equation. So that is the capital BB equals to small m1 plus CMR. Okay, the formula is there, small m plus cm into r. So just substituted the values. So capital B is unknown and small b is also given 0.4, and m1 is the 37 and c is the two-third and small m is the 50, r is the 0.15. just substituted the values. When we substituted the values in our equation, then simply to get the our unknown, so that is the capital B equals to 26.38 kg. 26.38 kg. So that is the, okay, that is the first unknown value. First unknown value. Okay. And now going to take the our second determining value for getting the second determining value. So theta value is also given. So that is the crank angle from TDC, that is 60 degrees is there. Now unbalanced force, residual unbalanced force. What is the final equation is there? So that is the m omega square r into square root of 1 minus c square cos square theta plus c square sin square theta. Okay, so just substitute the values in this equation. So small m is there, m is the 50 and omega is the already calculated in earlier. So that is the 25.4 and small r is the 0.15 and c is known. Okay, just substitute the values in our equation and calculate the value. So simply you will get the value. So that is the 2849 newtons. 2849 newtons.